Today we discuss waveguide. Now waveguide means it is a hollow tube typically made of metal used to transport EM waves from one point to another with the minimal energy loss. EM wave propagate using the principle of total internal reflection. Here we discuss the three modes of the waveguides, which is TE mode, TM mode, and TEM mode. Now we first discuss TE mode. We consider rectangular waveguide. Whose side are A and V. Basically, TE mode means the transfer component of electric field will be 0. Only the transfer component of magnetic field is non-zero. So Vz equal to B0 cos m pi x by a cos n pi y by a b. Now we see some properties of the T mode, which are properties. First one, lowest mode in TE will be PE10 or TE01. Now cutoff frequency. Cutoff frequency FC will be C by 2 root over of m by ether whole square plus n by ether whole square. Cutoff wavelength lambda c will be C by 2 root over of m by ether whole square plus n by ether whole square. Next we see dispersion relation. Number 3, dispersion relation. The dispersion relation in waveguide will be omega g square equal to omega square minus omega m n square. So here we write omega g equal to k square c square equals to omega square minus omega m n square. We write k square c square by omega square equal to 1 minus omega m n square by omega square. So we get c square by vp square equal to 1 minus omega m n square minus omega square. So vp equal to c by root over of 1 minus omega mn square by omega square. This is the formula for phase velocity. One important thing will be the product of phase velocity into group velocity will be equal to c square. So Vg will be c into root over of 1 minus omega mn square by omega square. Vp equal to omega by k. So this is for TE mode. Next we see TM mode. In TM mode there will be only EZ component. The transverse magnetic field Bz equals to 0. So equation will be Ez equal to E0 sin m pi x by a into sin n pi y by v. So lowest mode will be, number one property is lowest mode. Lowest mode will be TM11. Number two, cutoff frequency. Cutoff frequency will be same as before. Fc will be c by 2 into root over m by a whole square plus n by v whole square. Dispersion relation will also same. Dispersion relation will be omega g square equal to omega square minus omega mn square. Now we write omega g as 2 pi c by lambda g the whole square. Omega square equal to 2 pi c by lambda 0 square minus omega mn square 2 pi c by lambda c. So from this we get lambda g square equals to lambda 0 square by 1 minus lambda g square by lambda c square. So lambda g will be lambda 0 by root over of 1 minus lambda g square by lambda c square. This is the formula for guided wavelength. Now more few important things. First, in TM mode. In TM mode, TM00, TM10, TM01 not possible. Number 2, in TE mode, TE00 not possible. And cutoff wavelength in TE mode always greater than cutoff wavelength in TM mode. Thank you.